और ये देखिए इनको आता है फिर भी हमको चिढ़ा रहे हैं। हाँ તમારે આવતું તો હશે જ ને એવું બધું. Good morning, everyone. So we will now continue with resistances. The last time we derived the formula for Joule heating, okay, and the power loss in a resistor or a device. And then we talked about series parallel combinations of resistors. Okay. Now, please remember what I've taught you about series and parallel, right? It is that in series, the charge flowing or the current is same and voltage is distributed or to be added, that is V is equal to V1 plus V2 plus V3, like we had in capacitors. And in parallel, the voltage is equal for all and the charge or the current is distributed, right? So in parallel, we have Q equal to Q1 plus Q2 plus Q3, or I is equal to I1 plus I2 plus I3, right? So again, just to remind all of you, look at this is parallel. Here current splits or distribute or is distributed, right? So total current I is equal to I1 plus I2 plus I3. And on the other hand, in series, because current has nowhere else to flow, so the current flowing is same, right? But the voltages are different, that is V1, V2 and V3, and when we add the three voltages, we'll get total voltage of the battery, that's V, right? So please remember these things, right? They help you to solve problems. Okay, so please keep that in mind. And now let's solve a question from the exercise. And that question is 3.3. Okay, question 3.3 from the exercise. So please read the question. I will just copy it over here and then we'll get started. Okay. Right. So here's the question. It has two parts, A and B. Right. Both are very, very simple. Right. આ ક્વેશ્ચન એક્ઝામમાં આવી જાય તો લોટરી સમજજો આ 10th સ્ટાન્ડર્ડ લેવલનો ક્વેશ્ચન છે. Okay. So let's start. So it says that there are three resistors, 1 ohm, 2 ohm and 3 ohm combined in series. So circuit draw કરી નાખવાની. Right. So this is R1, R2, R3, all in series. What is the total? Again, total is actually the wrong word. We should write equivalent. All right. We should write equivalent resistance. So R equivalent in series is of course 6 ohm. આમાં કઈ હું કરાવવાનો નથી હો. બરાબર, નો સમજાય તો વાંધો નહીં. Right? Now part B. If the combination is connected to battery of EMF 12 volt and negligible internal resistance. Okay. See, I know these words are new for you. Don't worry about those, right? They have no effect on this question. Just understand that this is a 12 volt battery. બાકી બધું ભૂલી જાઓ. બાકી બધું છોડી દો મારી પર, તમને આવડી જશે. Don't worry, right? So just consider that we are connecting this combination, means all the three resistors together like this, with a 12 volt battery. Okay, what is EMF? What is meaning of internal resistance? Don't worry about that right now. Okay, it is a part of this chapter itself. All right, but it has no effect on your understanding of this question. All right, so just don't worry. So this is what we know. Then we have to find potential drop. Potential drop means potential difference, right? Voltage. So we have to find voltage across each resistor. Okay, so see, this is connected with a 12 volt battery, isn't it? So each resistor has voltage 12 volt. Clear? Yes or no? Each resistor has voltage 12 volt. Clear? Yes or no? આટલા જ લોકો છે ક્લાસમાં. There are 52, 56 now, right? Where are the other 40? Where are the other 40? એટલે ફોન ચાલુ કરી કે લેપટોપ ચાલુ કરીને બ્રશ કરવા કે નાહવા નથી વયા ગયા ને? Okay, now we have 25. We still have 30 more people. Probably facing the mirror, brushing. અને આટલા બધા લોકો yes કે છે. This is joke. This is wrong. હું તો ખાલી તમને ઉઠાડતો હતો આજે સન્ડે. This is absolutely wrong. This is nonsense of the highest order. અને તોય ઘણા બધા yes ને clear ને okay કહી દીધું. હે રે હજી ઊંઘમાં જ લાગો છો બધા. ઉઠો ઉઠો જરાક, હલાવો પોતાને. એકાદી ઝાપડ વાપડ મારો, ઊભા થાવ. એલાર્મ વગાડો, એલાર્મ. People, these are in series. તો સિરીઝમાં વોલ્ટેજ સેમ હોય. હે what is same for series? What is same for series? What is same for series? And voltage is distributed or divided, એવું લખાયું હતું ને? or voltage is added. તો શું થશે? same for series, current is same and voltage is added. ત્રણેયના અલગ અલગ હશે. we don't know. ત્રણેય થોડા 12 હોય. 12 plus 12 plus 12 equal to 12. વાહ, congratulations, you just passed first standard maths. એટલે થોડુંક ધ્યાન રાખો. કેમ આવું કર્યું આજે? બરોબર ને? ખબર પડી ને? સિવિયર, યુ જસ્ટ મેડ અ વેરી વેરી બેડ મિસ્ટેક. ઉઠી ગયા છે હવે બધા? ઉઠી ગયા જ ને? મિસ્ટેક ખબર પડી ગઈ? જે લોકોએ યસ કીધું તું પહેલા? હજી તો ઘણાય નથી, હજી ઘણાને નથી ખબર પડી એવું લાગે છે. Okay, I think all of you need to be aware and alert. ચલો તો હવે આનો આન્સર ફાઇન્ડ કરીએ ને. આ બધું તો ખોટું હતું. આ તો હું તમને તમારી સાથે સન્ડે ફંડે કરતો હતો. Okay, so first of all, to find the voltage, we are going to have to find the current. તો પહેલા છે ને current find કરીએ, right? So current in the circuit, કે current in each resistor, જે લખો એ current in circuit or current in each resistor same જ છે. I is equal to V by R equivalent, which is equal to 12 by 6. Clear? આના બહુ બધા શોર્ટકટ છે, પણ શોર્ટકટનું બહુ ટેન્શન ન લો અત્યારે, રાઈટ? પછી હું અહીંયાથી તમને શોર્ટકટ સમજાવી નહીં શકું અને તમને એમ થશે કે કંઈ ખબર પડતી નથી, સરે કેવી રીતે કરી નાખ્યું. Okay, I is V by R equivalent, so this is 12 by 6, 2 ampere. Now let's talk about voltage. Okay, voltage across each resistor. Now this is very simple. Think about it. Voltage find કરવો છે, current ખબર છે. ખબર ને current? Right? We know the current, isn't it? Right? And we also know the resistance. બરાબર ને? Resistance આપ્યું ને 2 ohm કે okay. શું આપ્યું છે? 1 ohm, sorry. So based on that, voltage across each resistor can be found easily. V1 equal to IR1. બરાબર ને? Ohm's law. Okay, we are just using the Ohm's law. Clear? તો થઈ ગયું ને? આ શું આવશે? 2 into 1 એટલે 2 વોલ્ટ. પછી V2 શું આવશે? શું આવશે V2? Hurry up, come on everyone, find the answers. Find the answers. V2, V3 બે કહી દો મને જલ્દી. I'm giving you 1 minute only. V2, V3 both. 1 minute only. Okay, very good. 4 volt and 6 volt. Okay, just confirm, everybody, please just confirm that is the total 12 or not? Is the total 12 volt? Yes or no? Right? And it's not a surprise. એવું થવું જ જોઈએ. એવું ન થાય તો મિસ્ટેક થઈ. બરાબર ને? I hope that makes sense. Right? Okay, very good. So that's it for this question. Next, હવે આના પછી exercise question 3.4. આના પછીનો જ question, exercise question 3.4. Okay, otherwise I would have given this for homework, but I was not very happy with what you all did, એટલે આ કરાવી દો. કદાચ કોઈને હજી થોડું કે કન્ફ્યુઝન હોય ને તો ક્લિયર થઈ જાય એટલે. બરાબર ને? ચલો ક્વેશ્ચન આવી ગયો. Okay. So what is given here? Draw the circuit. Please everyone must draw the circuit diagram. એના વગર તો બધું નકામું. Okay. So draw circuit diagram. 3 resistors, 2 ohm એટલે R1 એટલે 2 ohm, R2 4 ohm and R3 5 ohm are combined or connected in parallel. બરાબર, તો ખાલી આટલી સર્કિટ નહીં ડ્રો કરવાની, આટલું ડ્રો કરી જ નાખવાનું. ઓકે, so this is what is given, right? What is the total? ફરીવાર mistake, total no કહેવાય, equivalent કહેવાય. So what is equivalent resistance? Find it everyone, come on, I'm not going to do it for you. Hurry up everybody, you have 1 minute only. Unit, everyone, it must have a unit. મિસ્ટેક ન પડી જાય, નહીં તો 9th માં મૂકી આવીશ પાછા તમને. So we are getting two variety of answers, 20 by 19 and 19 by 20. Which is right? It's going to be 20 by 19 ohm. Okay, 20 by 19 ohm. Right? So that's it. Fine. Now, if the combination is connected to a battery of 20 volt, again same thing, EMF 20 volt, negligible, you ignore all that, just focus on this. Right? So here we are connecting it with a battery, right? With a battery of 20 volt. All right? So now, what is the current drawn through or current through each resistor? Okay, Tanai, no problem. Right, now we have to find current for each resistor. Yes, Khodal, you are right. Yes, Ramyak, you are right about that. So now here there will be 3 different currents. I hope you remember. Right? I hope all of you realize that there are 3 different currents, right? One for second, one for third. But what is same? What will be same, people? What will be same? What will be same? Yes, the voltage will be same. Very good. So we can easily find out current through resistors, okay, is I1 equal to K the correct. What will we do? I1 equal to K the correct. Yes, use Ohm's law. Very good. So V by R1, because voltage is same. Nitar to આવું લખું છે. See, actually it is V1 by R1. Actually it is V1 by R1, but V is same, so you don't need to worry about it. So this is going to be 20 by R1. That is 2 છે ને, કેટલું છે? First resistance. Yes, 2. So this is going to be 10 ampere. Clear? Okay. Second, like this you can find the remaining. Very good, hurry up, come on. Like this you can easily find the remaining. Do it. Okay, so yes, the answers are going to be 5 ampere and I3 will be 4 ampere, right? So now there is one more thing to be found. What is the total current from the battery? That is I here, right? Okay, so what's the current flowing here in the battery or through the battery, right? Current drawn through the battery. So of course, I hope you remember that in parallel the voltage is added sorry, the current is added, right, as resistors are in parallel. એવું લખી નાખવાનું. As resistors are in parallel, the current is added. So we get this is equal to 19 ampere. Okay. Right. Now I just want, I want to know how much do you think, right? I'm asking you, I'm asking you, is there any other method to find this? Is there any other method to find I is equal to 19 ampere finding without finding I1, I2 and I3? Is there any other method? If yes, what is the method? Is there any other method to find this without finding this? Yes or no? Let's see how much you think about it. Yes or no? Is there any other method? What's the method, everyone? If you know what's the method, write the method. Okay, very good. So many of you have given the correct answer. No, not at all, Chaitya. આગળનું કરવા જા, હજી આ પાછળનું તો બરાબર શીખી લે પેલા. નો ધવલ, એ તો આ જ કર્યું તે. No, Swarali, we did, that's exactly what you have done here, right? Yes, as many of you have said, the correct answer is this. If you do this, you will get it directly. See, isn't it? Have you given an answer? You know, have you? Okay, so I hope you have understood this other method also, those who couldn't give the answer in time, right? Yes, okay. It is better to know 3 ways to do the same thing, right, rather than knowing only one way. So whenever possible, try to look for alternate methods. એનાથી તમારી speed વધે. બરાબર ને? Okay. Now, time to give you some homework question, right? And that is exercise question 20 is homework. Oh. Exercise question 20 is homework. Okay, that's homework. All right. Now, let's go to the next. Now, we are going to talk about the theory, right? We're going to talk about a theory. And that theory is about cells. Cells means like battery, correct? Cells are like battery, but you know, basically there is a simple difference or simple distinction between them. They are not exactly same, right? They're not exactly same, right? So what is a cell? Cell is anything, any kind of you know, construction. Cell is any kind of construction, right, that has chemical reactions, okay, going on inside it, right? I'm giving you a very simple meaning of cell, okay? You don't have to worry about its definition, right? Cell is any kind of construction that has chemical reactions going on inside it, right? And because of these chemical reactions, it gives potential difference. It gives or provides potential difference. Basically એની અંદર છે ને ઓક્સિડેશન રિડક્શન થતું હોય એવું તમારે કેમિસ્ટ્રીમાં કદાચ ચાલી ગયું હોય તો ખબર નહીં. Have you studied the chapter electrochemistry? Is that chapter done? Have you studied electrochemistry? કોઈ કે આમાં લખ્યું છે cells can store. I would actually say cells don't really store. એ નાના છોકરાઓ માટે હતું, right? Cells don't store anything. Okay, ખરેખર એવું હોય કે I'm sure you realize that whenever molecules are formed, whenever some molecules are there, right? Molecules have their own potential energy. હવે તમે બહુ મોટા થઈ ગયા છો, right? So you should be able to understand this exactly. What happens is molecules are formed, right? And molecules obviously store potential energy. And when reactions occur, when different kinds of reaction occur, such energy is released. એવું આવે ને કે ન આવે? Right? And when potential energy is released, right, it typically causes motion or flow. Right? When potential energy is released, it causes motion. Right? એટલે શું થાય ખબર છે? The molecule's potential energy, I repeat, the molecule's potential energy, which is in the chemical form, okay, right, is converted into electrical potential energy. I repeat, the molecule's potential energy, which is due to the atoms atoms in the molecules, right, atoms and whatever bonds and blah blah blah, all the chemistry side, right? We will not go on this side. Okay, I'll make it very clear. We will not go on the chemical side, right? But I can at least give you the basic idea, right? So in the molecules there is chemical potential energy stored, right, which is due to the atoms and all that bonds and everything, right? And when some reactions will occur, that energy is released, and finally it shows itself as electrical potential energy, or it shows itself as potential difference, because I hope you realize that electrical potential energy can easily be written like this, correct? Okay, the difference of potential energy will show as potential difference. So that is what cells do. So cells ultimately provide potential difference. Okay, cells provide potential difference. बहुत short માં કેવું હોય, what is function or role of cell? What is role of cell? Then shortest answer is it provides potential difference, right? Okay, ઘણા લોકો એવું વિચારતા હોય છે કે એવું કહેવાય કે cells provide current. Right? Some people say that cells make charge flow. Right? Some people say that cells make charges flow. So they provide current. I would say no, this is wrong. This is wrong. નાના છોકરાઓ હતા ને ત્યારે બરાબર, હવે ખોટું. બરાબર ને? કેમ? સમજાવું તમને. Let's say this is a battery or a cell, બરાબર? Let's say this is a cell. આ cell જોઈએ ને, pencil cell. Okay, let's say you bought it new from the market, right? You have just opened up a packet. So is current flowing? I'm asking you. This is such a nice cell. Is current flowing? તો પછી એટલું તો સમજાય ને. cells don't make charges flow, right? Cells don't provide current. Current છે ને cell ના કારણે flow નથી થતો. You should understand that, right? Current cell ના કારણે flow નથી થતો, first of all, right? But yes, what cell definitely does is that between this end and this end, cell creates a potential difference. Suppose as an example, okay, as an example, it creates a potential difference 1.5 volt. Okay, so હવે શું થશે? Now if you will connect it with a wire, if you will connect it with a metal wire, ne suppose અહીંયા bulb રાખ્યો છે, okay, this is a bulb, let's say, right? Then electrons are very opportunistic, right? અહીંયા છે ને electrons ની meeting ચાલુ થશે. Okay, right, we are seeing that on this side, if we go over here, the potential energy will be less. All right, okay, that's what electrons are seeing. So electrons will say march. Okay, The leader of electrons will say march, and now electrons will start drifting in the wire, right? And tada, there will be light. Okay. Fine. So you should remember that electrons could flow or charge could flow because there was a conductor, because there was a wire, right? ખાલી હવામાંથી flow નહોતા થતા. So battery did not make, or cell did not make the charge flow. But yes, cell has its role. Cell's role was this. સેલે કહી દીધું, જો તમે અહીંયા આવશો ને તો હું તમને 1.5 into 1.6 into 10 raised to minus 19 joule energy ઓછી કરી દઈશ. ઓકે, એવી સેલે લાલચ આપી. પછી ઇલેક્ટ્રોન આવે કે નહીં, that depends. બરાબર ને? You get current. તને don't try anything crazy. કોઈને કહેતો નહીં કરંટ નથી લાગતો, લાગે જ છે. માણસો ચોંટી જાય છે તો શું અમથા મરી જાય તને? Right? The thing is, our body's resistance is significantly high. Our body's resistance is significantly high. બરાબર? એટલે આ 1.5 વોલ્ટના સેલને તમે બે બાજુ અડી જાઓ તો ડિવાઈડ બાય આર ઓફ યોર બોડી કરો તો કઈ એમાં બહુ તકલીફ ન પડે. રાઈટ? I hope you understood that. Right? At about 12 volt, you will start to feel a tingle. Right? You'll get a tingling sensation at 12 volt. Right? Okay. So that's because at 12 volt there will be some small current flowing. Right? At 12 volt there will be some small current flowing through your body. Right? So if the voltage is high, you definitely feel it. Right? So in fact, high voltage or high current both could kill people. Right? Even high current is harmful to your body. Right? It's not like only high voltage is required. Right? But anyways, coming back to the topic. Right? So that's a cell. Cell provides potential difference. પછી charge flow થાય કે નહીં? Well, Vishwa, it's okay. So let me complete what I was saying. Cell provides potential difference. Then whether the charge flows or not, that depends on how much is the resistance between the two, right? એટલે અહીંયા insulator હોય તો flow ન થાય. If there is a very good conductor, it will flow easily. એવી રીતે, right? Okay. Yeah. So Vishwa is asking a question, how much current we can handle? Well, I don't think there is an exact study, right? Okay. But I think about 1 ampere can start to become dangerous. Right? About 1 ampere starts to become dangerous. Right? No, Kodal, battery and cell are not exactly the same thing. They are slightly different. I'm coming to that. Okay. Okay. So what is the difference between battery and a cell? Right. Very simple. Combination of cells is called battery. Okay. That's the difference. Got it? Combination of cells is called battery. Absolutely wrong, Avinash. 45 milliampere એ તો સાવ ખોટું છે. Battery down is nothing, Sumit. Battery down is what we we say that it has no meaning. It means battery cannot supply energy anymore. That means battery down. Avinash, what you are talking about, 15 to 45 milliampere, RCB trip said that is wrong. I don't agree with it. I think you are making a mistake somewhere. આટલો ઓછો કરંટ તો કોઈ ન લે. You should understand that. 15 milliampere at 220 volt. 15 milliampere at 220 volt is only a power of 15 into 0.22, right? એટલે સપોઝ આને હાયર એસ્ટિમેટ કરો તો આને 0.25 લખો તો આ કેટલું થાય? હે, this is just 3.75 watt. This is nonsense. 3.75 watt માં તો બલ્બે ન ચાલુ થાય, બરાબર ને? So what the figures that you have quoted are definitely wrong. What you have read, you have misunderstood. What you have read is that MCB, what you have read is that MCB consumes that much power, okay? And MCB continuously consumes that much power to check whether there is a current leakage or not, okay? If there is high current, then MCB will not trip. What nonsense. Well, frankly, see, again, MCB has a lot of electronics, right? And many electronic devices behave in a very different way because we can design them to be like that, okay? So your region of interest is definitely miles away from this chapter, right? So I wouldn't like to take the discussion too much on that side, right? But it's a truth that MCBs will only trip when there is a short circuit, and short circuits occur and they cause the current to be high, right? That is what is called a short circuit, right? Okay, let's go to the next thing now. Combination of cells is called a battery. That's it, right? That's the only difference between a cell and a battery. Baki badu function badu same જ છે. Okay, let's go to the next. Now, terminal voltage. See, now we are going to talk about very important terms about batteries or cells. Okay, જે આ terms નહીં સમજે એને બહુ તકલીફ પડશે. So, terminal voltage. First of all, what is meaning of terminal? Terminal means ends, right? Terminals means ends. તમે કોઈ પણ battery કે cell જો, let's say it's like this. Okay, this is a cell. So this cell has two terminals. Which two terminals? Here, positive terminal, and here, negative terminal. Okay, I hope everyone understands that, right? Okay, so here there is a terminal, positive terminal, right? This is called the positive terminal, and this is called the negative terminal. Okay, so now what we are having here is that if we connect it with something, like let's say maybe we have connected with it with a bulb, right? Let's say this is a bulb, right? Okay, so bulb will be glowing, correct? And bulb will have its own resistance, right? Bulb obviously has its own resistance. So at this moment, right, at this moment, if somehow you'd calculate or somehow you'd find out, if you find out what's the potential difference potential difference between the terminals, or between the positive terminal and negative terminal of a battery or a cell. જે લખો એ કંઈ ફરક નથી પડતો, because battery is just nothing but a combination of cells, right? So potential difference between positive terminal and negative terminal of a battery or a cell is called terminal voltage, right? So it's nothing but the potential difference or voltage between two terminals. How do we measure it? We can measure it by measure it by voltmeter. Have you heard that word? Have you heard this? Do you know of voltmeter? It is a device that is used to measure voltage. It is a device that is used to measure voltage, right? Okay, right? So its symbol is V. Again, see, I know it can get confusing. The symbol of terminal voltage is V, right? Symbol of terminal voltage is V, right? V for voltage, like that. Now let me draw a detailed view of what a cell looks like, right? I'm absolutely sure you have this idea that a cell, I'm absolutely sure that you know that a cell has two terminals or two electrodes, right? Okay, and typically these electrodes are made up of metals, but sometimes they're also made of graphite or platinum, right? Such strange or different materials, right? So what I'm saying is that suppose you have connected some resistor or some bulb or anything, okay, it doesn't matter. Okay, suppose you have connected this cell. This is a cell, right? What I've drawn in a box is a cell. Let me just draw it once again. I'm not very happy with what I've drawn here, right? I just want a bit more space, maybe. Okay, so suppose why can't I draw it straight? I don't understand. So suppose here is a resistor or a bulb, anything, right? Any kind of device that you might be using, right, can be connected here. And this end, let's say, is connected to the positive terminal, right, which is going to be an electrode. And this opposite end also is connected with another electrode or the negative terminal, all right? So these are the two terminals of the battery, right? This is internal design. I want all of you to understand that this is the internal design of the battery, right? This is what we are trying to represent. Okay, so where's the battery? This whole thing is the battery, right? Okay, all the resistor જે draw કર્યું છે ને એ બાર છે. I hope that makes sense to all of you, right? So these are the two electrodes of the battery. And typically what happens is between the two electrodes, there is, some kind of fluid or gel or something, all right? There is some kind of fluid or some kind of gel, or if it's a dry cell, right? There are a few things called dry cell. Dry cell has something like powder. So basically there is some material here. You should understand that there is some kind of material, right? In many batteries it's a fluid. અરે યાર બે શું કીધું હમણાં? સેલ અને બેટરી વચ્ચે શું ફરક છે? શું ફરક છે બે વચ્ચે? મલ્ટિપલ સેલ્સ આર કોલ્ડ બેટરી ટુગેધર, ઓલરાઈટ? તો આ જે તમે કાર બેટરીઝ ને એવું બધું તમે જોવો છો ને, એમાં શું હોય ખબર છે? એમાં 1 2 3 4 5 6 આવી રીતે છે ને ઇલેક્ટ્રોડ્સ હોય, એટલા બધા ઇલેક્ટ્રોડ્સ હોય, right? So these are multiple cells, cell 1, cell 2, cell 3, cell 4, cell 5, એવી રીતે સમજાણું, right? and everything, and in between everywhere over here there is a material, right? If it's a liquid or lead acid battery, then there is a fluid, right? In some batteries there is something like a gel, but એ બધી લપમાં ખરેખર કઈ પડવા જેવું છે નહીં, right? Whether it's a cell or a battery, it makes no difference to this discussion, right? Okay, Vishwa, that you are going to study in chemistry. In different kinds of cells, there are different powders or different fluids. Like I have mentioned earlier, I am not going to tell you a lot on the chemistry side. Whatever, okay, that's not really what this discussion is about, right? There are different kinds of powders depending on type of cell. Okay, so here, so there is some material inside, right? There is some material inside it, right? So let's say that this point is P. કેમ એને હું P કહું છું ખબર છે? Because that's the positive terminal. Suppose let's say this end is the positive terminal, એટલે બેટરીમાં અહીંયા પ્લસ લખ્યો છે અને અહીંયા માઇનસ લખ્યો છે. Okay, all right, and let's say this is N for negative terminal. All right, now I'm going to say that suppose there's a point A here very close to this electrode. Okay, very close to this electrode. All right, let's say that there is a point A very close to this electrode, and there is a point B here which is very close to this electrode. Okay, let's say there is a point B here which is very close to this electrode. Now I hope all of you would realize what's going to happen is that when current will flow, let's say that there was nothing at start, okay, and then you connect a resistor or some device, so now current will start to flow. So how will the current flow? Current will come out from the positive side, so it has to go through this, and it will come in, and it will come in like this. All right, is that okay? So that's how the current will flow. But then see, I'm sure all of you realize that current must flow in a loop. What I mean to say is, what is actually going on is that electrons will come out from here. That is, negative charge will come out from here. Electrons will flow all the way through this, and they will reach here. Correct? Is that okay? But if that would continue, so આ positive થઈ જાય. I hope you understand what I'm saying, right? I hope you understand what I am saying, right? If electrons would continuously leave, from here, right, after some time this would get a positive charge and this would get a negative charge, then I'm sure it would stop, the process would stop, right? I'm coming to the loop. It will be closed loop only. પણ હું સમજાવું છું હજી કે closed loop કેમ હોવું જોઈએ, right? So if it would be only this much, if charge would only flow from here to there, right, then there would actually be a problem. It would not work. Okay. So what's happening is that negative charge, that is electrons, will flow in the wire and they will reach here. They will reach this point. But then from this electrode, those electrons will do some chemical reactions. Typically they will do reduction. I hope all of you know that much chemistry, that electrons will do reduction. Okay, so those electrons will do some reduction, and then some negative ion will flow from here to there. And you see, this is how loop is completed. Is that clear? Some negative ion will flow from this point A to the point B, and the loop is completed. So how did negative charge flow? First of all, electrons flow in the wire like this. All right, Okay, so electrons are flowing in this manner. Okay, but then this last part is completed by negative ions, and negative ions will flow from here to there. So I hope all of you realize that there is a loop. Okay, I hope everyone realizes that there is actually a loop. Clear? Right? ધવલ ઓપન ને જનરલી લૂપ નો કહેવાય ને, લૂપ કોને કહેવાય? What is a loop? Loop is typically closed, right? So you can actually say that it's on a closed path, right? Charges must flow on a closed path, right? So three parts of that path, or the wire part, is completed by electrons. But that part inside the battery, electrons are not flowing. Inside the battery, between the two electrodes, ions are flowing. All right, I hope that makes total sense to all of you, right? Again, I'm not telling you the exact picture. મને આવડે છે આનું પાછળનું બધું કેમેસ્ટ્રી, પણ એ બધું તમે કેમેસ્ટ્રીમાં શીખજો. ફિઝિક્સની બુકમાં એનું કંઈ જ લખેલું નથી, એટલે ખોટું એ બધું હું સમજાવવા રહીશ ને તો તમે જે સમજવાનું છે ને એ તમને નહીં ખબર પડે, રાઈટ? ટોપિક પછી આ 3-4 કલાક ચાલશે, એવડો મોટો છે, કારણ કે આખું મારે તમને ઇલેક્ટ્રોકેમિસ્ટ્રી સમજાવવું પડે. Okay, so we'll not go on that side, but I hope you understood that there is a loop completed, right? Okay, so current must definitely flow here. Okay, between the two electrodes, some current must definitely flow. If current is flowing here, I repeat, if there is a current I outside, if there is a current I outside, okay, then there will be, if there is a current I outside, then there will be a current inside also, like this. Clear? I hope everyone is seeing that the loop is completed, right? કેવી રીતે અહીંથી આમ, all right, and then here. Agreed? Okay, so current is flowing through the material of the battery. Do you agree with that sentence? Let me write that. Current flows also through material of battery, right? Current flows also through the material of battery. Okay, just give me a moment, I'll be back very soon. Okay, we are not taking a break at the moment, but just a moment. Okay. Okay, so let's continue. So I'm saying that current is flowing through the material of the battery also, right? Now any kind of material, listen to this carefully, any kind of material, right? Whatever this material is, right? Whatever this material is, fluid, solid, doesn't matter. Any kind of material definitely has a resistance. All right, okay, so we can say that the resistance of internal parts or structure, the resistance of internal parts or structure of battery or cell, again, is called internal resistance. Okay, right? This is a new word for all of you, but its meaning is very simple, right? Internal resistance એટલે બેટરીની અંદર કે સેલની અંદર જે રેઝિસ્ટન્સ છે ને એને ઇન્ટરનલ રેઝિસ્ટન્સ કહેવાય, right? And see, this is unavoidable. I hope you realize, I hope all of you realize that this is unavoidable. Why? બેટરી યુઝ કરવી હશે, બેટરી યુઝ કરવી હશે ને તો અંદર મટીરિયલ એ હશે જ ને, મટીરિયલ વગર તો બેટરી ચાલે નહીં, right? So if you want to use a battery, then you have to take a material in it, right? Some chemical, something, and that something will definitely have a resistance. So that would mean that whenever you use a battery, there's always an internal resistance of that battery. It is unavoidable. એવી કોઈ એવો કોઈ સેલ, એવી કોઈ બેટરી બનાવી જ ન શકાય which has no internal resistance. All right, is this clear that this is unavoidable? Yes or no? Okay, now let me write the symbol. Symbol of internal resistance. Symbol of internal resistance is R. Okay, small r, not capital, never capital, people. Symbol of internal resistance is small r. Okay, never use capital for this. All right, and we can say that for real cells or batteries, R is always greater than 0, and for ideal cell, ideal જે છે નહીં કોઈ દિવસ, right, for ideal cell or ideal battery, R is equal to 0. Okay, yes Avinash, you are right about that. Okay, so now this is what is internal resistance. Okay, right, so far we have talked about two terms. Which two terms? One, terminal voltage, right? That's the first term which we have talked about, terminal voltage. All right, what's terminal voltage? It's the potential difference between this end and this end, that is the positive terminal and negative terminal, right? Then we have talked about internal resistance, that is the resistance which is due to the material or the internal parts of the battery or cell, right? It is unavoidable. Battery use કરવી હોય તો ઈ તો આવશે જ, right? Okay, and ideal cells or ideal batteries will have R equal to 0. For real battery, R is definitely greater than 0. તમે ગમે કરો જાય નહીં. Okay, you can minimize it, but you can never make it 0, right? Okay, so that's for these two things, right? હવે આના પછી થર્ડ સૌથી ઇમ્પોર્ટન્ટ આવે છે EMF. Okay, but before that we will take a break. We'll continue once again at 10 hours and 5 minutes. Okay, so about 4 to 5 minutes break. Okay, so you could freshen yourselves up. You can just take your eyes off the screen, no problem. Okay, and we will continue after that time. Okay, everyone, I hope you all are back. Let's start. Okay, right. Now, now we are going to talk about EMF, right? So let's start with that. So you could put the title EMF, right? Okay, right? EMF actually stands for electromotive force. Okay, the full form of EMF is electromotive force, right? But this is not a force. Remember, this is not a force. Although the name says that, but this is still not a force. Clear? Right? You should be careful. Electromotive force is not actually a force. એનું નામ એવું છે. The name is misleading, right? Be careful, everyone. The name is misleading. It's not a force. Okay. So the symbol of electromotive force is epsilon. I'm so sorry. We're using the same symbol once again, right? The symbol is epsilon. Okay. Right. Okay. Right. So now what is this electromotive force, right? What is EMF? What is meaning of this? Let's talk about that. So first of all, I think it's quite quite the right way if I tell you the definition first, and then we'll talk about what's the meaning of this thing, right? So the definition. Okay. The definition is the potential difference between the positive terminal that's P, of course, and the negative terminal, right? If you remember in the diagram, we have drawn P and N, right? Okay, so the potential difference between the positive terminal and the negative terminal in open circuit, right? In open circuit situation, right? That is when current flowing is zero, right? You could put that in brackets, right? Potential difference between the positive terminal and negative terminal in open circuit situation. What is meaning of open circuit situation? It means current flowing is zero, right? If you want, you can write it further. That is no current is flowing through the battery or through the cell, right? Okay, so that is the meaning of open circuit situation, and this is the definition. This whole thing is the definition of EMF. Right now, you might already have a question like, how is this different from terminal voltage, right? Okay, so for that you'll have to read it very carefully, right? So I agree, I repeat, I agree that this is the first part is same, potential difference between positive terminal and negative terminal. Okay, I forgot to write N here, right? Okay, so what does that look like? Suppose that, yes, exactly, Coder. So the difference is as follows. If this is, let's say, the positive terminal of battery, and let's say this is the negative terminal of the battery, all right? And like I said, here's the point P, here's the point N, right? Here's the point P and here's the point N, right? The positive and the negative terminal, right? So when you connect a resistor, right, or any other device, right, resistor or any other device, maybe a bulb or anything, right? Okay, so when we connect a device or a resistor here, then current will start to flow, right? Current will start to flow. Okay, but in this EMF thing, we want to measure this. I repeat, it is called EMF only when the current is not, current is not flowing, right? Only when the current is zero, right? It's called EMF only when the current is not flowing. So that is only possible if the circuit is open. Open that is switch ચાલુ નથી કરી કે કઈ લગાડ્યું જ નથી એમને. I hope you got what I said. આ ખાલી એમને battery પડી છે, right? Okay, so when the battery is just lying idle and it is not having any current flowing through it, at that time the potential difference between positive terminal and negative terminal, I repeat, at that time the potential difference between positive terminal and negative terminal will be called EMF. Did you understand this whole thing, this whole equation? Yes or no? All right. So how is it different from terminal voltage? Terminal voltage can be Vp minus Vn in any case. Remember this, everybody. V is equal to Vp minus Vn in any case. Clear? Right? That is always true. Right? This is always true. But it is called epsilon or EMF only if current is not flowing. If current is flowing, you definitely call it terminal voltage. I hope that makes the difference very clear, right? Okay. All right. So I have 3 questions now. Let me answer them one by one. Okay. First of all, if we attach it to any device but remove material inside, then it will be EMF. You mean to say, Swarali, that suppose we connect it, let's say, with a bulb here, right? This is a bulb. Okay. At that time, there was all material inside. Okay. Right? And then you, while this is working, while this current is flowing and while the bulb is glowing, if you remove this material by breaking the battery, simple, it will stop working, because batteries don't work without their material. It is impossible. If battery chemical ઉપર તો ચાલે છે, right? If there is no chemical, if there is no material, it will not work. Okay, so what you are suggesting will only lead to stopping that circuit, right? So પછી એને EMF એ ન કહેવાય, because now the battery doesn't exist, right? Because if you remove the material, there is no battery, right? એના વગર તો એ કંઈ કરશે જ નહીં. I hope that makes it very clear. Okay, why the name electromotive force? That's the next question. See, earlier, listen to this. Earlier, people did not have a very good idea of all electrostatics and how chemicals work and everything. So they thought that batteries or cells, anything, right? They thought that batteries or cells apply force on electrons or force on charges actually. Apply force on charges. That's what they thought. Okay. But that's not entirely true, right? Okay. What batteries and cells are doing is they just create potential difference or voltage, right? They give a voltage, correct? So this name has been given since a lot of time, right? It's a very old word. So at that time people didn't know the exact thing, so they thought it's a force, or they thought that batteries are giving a force. That's why they called it electromotive force, right? But ultimately we realize that it's not a force. Okay. And this is just due to historical reasons, and we have not changed, right? Just like we know that electrons are flowing, we know that electrons are flowing like this, but we still don't say that current is flowing in this direction. We say that current is flowing in this direction, right? Yes, old convention, exactly. This is old convention, right? Okay. Now, third one, Codal. Can we say EMF is a type of terminal voltage? Yes. Everyone, yes. EMF is a special case of terminal voltage. I hope all of you realize that. Okay, right? I hope you understood that, right? EMF is a special case of terminal voltage. Are batteries heavy due to this specific material? Exactly. એની અંદર મટીરિયલ ઠાંસી ઠાંસીને ભર્યું હોય, એવું ભરે નહીં તો બેટરી ચાલે નહીં વધારે, right? That's why they are very heavy generally. There are some new kinds of batteries which are not that heavy, right? But again, we don't want to go too much on the chemistry side, so we'll not talk about that. Okay. Now, so now we are going to see what is the relation between these three things. So far, we have been talking about terminal voltage, EMF, and internal resistance. Correct. Now we are going to talk about a relation between these three. Okay. I'll just clean up this diagram a little bit. We want to use it. Okay. કેટલી વાર હું ડાયાગ્રામ ડ્રો કરીશ? બોર્ડ પર તો સારું પડતું હતું, ખાલી એટલો પાર્ટ ભૂસી નાખીએ તો ચાલે. Okay. So let's say that this is a typical battery, right, or cell. Again, here is point A and point B. Okay, very close there. So now first of all, consider that when this is connected and there is a current I flowing in it, and this resistance is R. All right, this resistance is R. So now I'm just going to erase all of this. I hope you have written it. Have you written all of this? And either nothing. Have you written this much? Okay. Okay. Fine. All right. Right. So now I'm going to use this diagram to get a relation between these three, right? So let's start with that. So first of all, do you realize that I can write V is equal to Vp minus Vn in any case? That is potential difference between the positive and the negative term. So by simple logic of few steps, I can write it like this. Okay, I don't think anyone has any problem with that. Okay, right? So now what we are talking about here is, what we are talking about over here is as follows. See, Vp minus Va, right, and Vb minus Vn can be left aside for right now. Focus on this. Okay, focus on this, right? So I'm saying that if current I is flowing, if current I is flowing like this, then current I will also flow like this. Agreed? Right? In fact, it will flow through this also. I hope that makes sense. I hope that makes sense. Right? Okay, right? But for simplicity, right now, see, I'm going to give you a very simple way to understand this. એટલે તમે વધારે પડતું કોમ્પ્લિકેશન કરશો ને તો તમને જ નહીં ખબર પડે, right? That's a fact. So listen to this very carefully. Right now, let's assume that these electrodes are made up of metal and ideal. Okay, let's assume that these electrodes are made up of metal and they are ideal. I know there is nothing ideal, I agree, but again, like I said, if you want to understand this very nicely, very smoothly, assume this for a while, then automatically everything will fall in place. So now, do you realize that this material which is filled between these two, right, filled between the point A and B, right, will have some internal resistance. This material obviously has some resistance, right? Okay, ક્યાંક તો resistance હોય. So let's say that internal resistance is R. Okay, I repeat, that internal resistance is R, right? So agree do you agree that because current is flowing from B to A, I repeat, because current is flowing from B to A, that's why Vb minus Va should be equal to I into small r? Yes or no? Yes or no, everyone? Is that clear? Right? Okay. See, why not Va minus Vb? I hope you realize Va minus Vb will not be IR. Right? This is wrong. It actually should be minus because current is flowing from B to A. Right? It's not flowing from A to B, it's flowing from B to A. Right? So if we use this here, I can write this as follows. Okay, same equation. Now I'm continuing with that same equation. Right? Yes, that's right. Higher potential to lower potential. Voltage potential. Right? So this is V equal to Vp minus Va plus Vb minus Vn separate. Okay, just write it like that. Okay, we don't want to do anything with it. Right? Minus IR. Is that clear? I don't think anyone has any problem with that. Right? I don't. Okay. So now, if you consider, right, let's consider a case. Let's consider a case. I equal to 0, that is open circuit. I equal to 0, that is open circuit. Okay. Right? I hope all of you get that. So in such a case, V should be equal to epsilon. Agreed? In such a case, V should be equal to epsilon. Yes or no? Do you understand this? I need definition, Jema. By the way, look at the definition. This is its definition, right? Isn't it? When current is not flowing, the potential difference between terminals is called EMF. Now, also, let's put it here. Okay, so let's put I equal to 0 and V equal to epsilon in this equation above. So we get, okay, so what do we get? Therefore, epsilon equal to, is it fine? So this is what we have got, minus 0. Why minus 0? Can you all say that? Correct. We are putting current's value 0, right? So we have got epsilon's value, right? Okay, we have got the value of epsilon. Nah, ideal case nothing, Vishwa. Open situation, open condition, open circuit. Okay. So now we take this value of Vp minus Va plus Vb minus Vl. We take this value and we go and put it here. So we get, thus, when current I flows. Okay, so thus when current I flows, what's happening? V is equal to, instead of all of this, epsilon minus I. Clear? Okay. So that's what we get, right? We get a relation between V, epsilon and IR. See, you might be thinking, is it not possible that, is it not possible that Vp, Va, Vb, Vn change if current is flowing? Okay, well, the answer is no. That's right, Avinash. શું લખવું છે જોઈ લો ફરી એકવાર પાછું પહેલેથી ચાલુ કરી. So if there is a battery, right? So the terminal voltage is V, which is Vp minus Va, right? And I can write that as Vp minus Va, Va minus Vb plus Vb minus Va. Okay. So what I'm doing is I'm separating the part from B to A where the material and everything of the battery is filled. Okay. Right? Then by Ohm's law, okay, by Ohm's law, I could say that potential difference is equal to I into R. Right? So I've put Vb minus Va is IR, so Va minus Vb is minus IR. So I've written it over here. Then we stop over there and we consider a special case where I is 0. Why are we considering that case? Because we want to talk about EMF, right? So if we put I is equal to 0, then voltage, terminal voltage will become EMF, right? That's its definition, right? So this whole thing becomes epsilon because here I is 0. I hope that makes complete sense to all of you, right? So finally, you have epsilon is this whole thing, but you are seeing that in this equation. So let's write it over there. So V is equal to epsilon minus IR, right? Okay. So this is a very, very, very important relation. All right. This is a very important relation. I was about to tell you, why do Vp, Va, Vb, and Vn don't change? Why is it that they don't change, right? The reason is, you're going to learn this in chemistry, but I'll just give you a basic idea. It's that these potentials are actually decided by chemicals or chemical reactions. Okay, you're going to study it in chemistry that whenever you take some electrode, right? Whenever you take some electrode and you take some, some solution or something like that, right? Electrolytic solution. Over here, some reaction will occur, right? Either oxidation or reduction. So that oxidation or reduction will cause a potential difference. I repeat, suppose here oxidation is occurring. So that oxidation will cause a potential difference between this point and this point. right? That is between the electrode and the solution, right? So that potential difference is just Vp minus Va, and on the other side it is Vn minus Vb minus Va, right? So these two depend only on chemistry and on nothing else, right? These differences, they depend only on chemistry, and that is what reaction is going on. That's it. Okay, like I said, you're going to study it in a lot more detail in electrochemistry chapter, but I think here this is enough, that these differences don't depend on anything, right? Okay, whatever is that battery made up of, that's it, it's fixed, it only depends on that. So that's why this epsilon actually becomes a property of the chemicals of battery. I hope you understand what I'm saying, right? This epsilon becomes property, or it depends on chemicals, right? Okay, it does not depend on other factors like how much is resistance, how much is current, nothing. Okay, clear what I've said? સુઈ ગયા લાગો છો? હા બરાબર, સુઈ ગયા. Okay, now let's talk about a slightly different way to have a look at this. See, if you will consider that an electron flows from this point to this point, okay, all right, if you'll consider that an electron flows from this point to this point, right? So basically, instead of electron, just think that it's like a relay race. Okay, we are just worried about charge. Okay, so to make negative charge flow from here to here, all right, when that happens, listen to this, when that happens, when the negative charge flows from here to there, right, what's going on is it's passing through the resistor, right? It's passing through the resistor. So here it will lose energy, correct? There is a loss of energy. Do you all remember that whenever it passes through a resistor or a bulb or any other device, there will be loss of that energy, correct? Okay, so then the question is that when next time, let's say, when next time that charge will, I mean, complete the loop, and now the charge has to flow back, right? Because charge is flowing continuously, right? How does it get energy? Who gives it that energy, right? Who gives it that energy which it can lose over there in the resistor? The answer is, listen to this carefully, the answer is non-electric forces. Okay, so what is meaning of non-electric forces, right? This is as follows. Suppose this is one electrode, here is another electrode, and let's say negative ion, suppose, wants to flow from here to there. Okay, let's say negative ion wants to flow from here to there, right? But in that process, what's going to happen is that here there will be an opposing non-electric force. So what happens is that when this ion moves or has a displacement against the non-electric force, right? Whenever something moves against a force, its potential energy will increase. Do you realize what I'm saying? Yes or no? Whenever something moves against a force, its potential energy will increase. Do you agree with that sentence? Right? Think about it, everybody. Think about it. If there is a spring like this, and let's say it is in natural state, and you put a block here and you try to push it, so spring will apply force in this direction, right? But you will make the block move towards left side. So potential energy of the spring will increase, right? And that's what we are talking about here, right? It's similar, right? It's similar to that. So because this ion will move opposite to the non-electric force. So what will happen is that this non-electric force will store potential energy due to Fne opposing its motion, right? Due to Fne opposing its motion, right? There will be energy stored or energy gained by the ion, okay, or by the charge, if you understand it that way, right? Okay, so what does it do with that energy? It's like, okay, ion will say, right, I've come here, right? But this non-electrical force has given me a lot of energy. And I'm sure you remember that potential energy is something that gets converted to other forms of energy in future, right? So this ion will take that potential energy from non-electric force and will give it to that electron. And it will say, go have fun, okay, enjoy the ride. So this electron will now go on this bumpy resistor ride, and then it will come here and say, oh, thaki gyo away, right? Okay. No, Avinash, that's why, see, it is very important to write this. What is meaning of non-electric forces? These are these are forces that don't have origin in charges of electrodes, right? See, let me let me clear a major misconception that most people in the world have, right? So you're about to enter probably less than 1% of the people of the world, okay, who know this. Listen to this very carefully. When we say that this terminal is positive and this terminal is negative, the truth is both terminals are neutral, right? They don't have charge. I repeat, they don't have charge. When we say that one terminal is positive and the other is negative, the truth is both terminals are neutral. They don't have any kind of charges, right? Neutral aj hoy. In fact, the moment they will get a charge, this battery will stop working, right? The moment they get a charge, this battery will stop working. તો પછી કેમ પોઝિટિવ નેગેટિવ કહેવાય, રાઈટ? અરે ઈ જ તો કન્વેન્શન છે. લોકોને એવું લાગ્યું કે પોઝિટિવ ચાર્જ અહીંથી બહાર આવે છે. ઓકે, people thought that positive charge comes out from here, right? So they thought that this is like a tank or a reservoir of positive charge. પડી ખબર? They thought that this is like a tank or a reservoir of positive charge. સમજી ગયા? But obviously this picture is rubbish. Okay, this picture is rubbish because charge is not a fluid. I hope all of you understand that charge is not a fluid, right? Exactly, Avina. What you said is perfect. If one electron will come out from here, at the same time one electron will enter this. Is that absolutely clear? Right? And at the same time one minus E charge will go from here to there in form of ion, of course, right? Okay, in form of ion, right? Batteries don't store charge. Again, another misconception that most people have. Batteries don't store charge. Okay, what creates Fne? Good question, right? In fact, I was waiting for someone to ask that so I could explain. So what are these forces then? Okay, these are not due to charges or repulsion or anything. What are these forces? Generally, in a battery or a cell, these are chemical forces. What do we mean by chemical forces? Please be very careful. By chemical forces, we mean, listen to this. By chemical forces, we mean that when chemical reactions occur, when chemical reactions occur, they create a concentration difference. બહુ વધારે નહીં કહું, આ બધું તમારે ઇલેક્ટ્રોકેમિસ્ટ્રીમાં આવશે. When chemical reactions occur, they create a concentration difference. So because of that, typically ions will tend to diffuse. Okay, because of that, typically ions will tend to diffuse. એટલે એ બધાથી આ non-electric forces, right? In a generator also gives current, isn't it? Right? Agreed or not? Generator gives a current. So એ થોડી battery છે. So any અંદર our non-electrical forces, right? Inside a generator also there are non-electrical forces, but there those non-electrical forces are due to magnetic field. Okay, there those non-electrical forces are due to magnetic fields. In batteries or cells, the non-electrical forces are due to chemical reactions. આટલો ફરક છે બેટરી અને જનરેટર વચ્ચે. ઓકે, clear? Again, if you are not satisfied with my chemistry answers, please remember that I've tried to keep it as short as possible, right? Because you are going to study this in full detail in electrochemistry. Sir, એના electrolytic aqueous solutions હોય ને, હા બરાબર એમ જ હોય પૂર્વેન્દ્ર, that's right. CuSO4 ને એવું બધું હોય, બરાબર ને? ડેનિયલ સેલ નામ સાંભળ્યું છે કોઈએ? ડેનિયલ સેલ. Okay, fine, all right. So what's the key thing to remember from all of this, right? Definition, ખાસ આવડવી જોઈએ. Definition of terminal voltage, right? Terminal voltage is the potential difference between the positive terminal and negative terminal. આમ જ તે ઊંધું નહીં. This is not valid, people. This is wrong. Okay, right? Okay, so then epsilon is the EMF, right? EMF no matlab થાય potential difference between positive and negative terminal when no current is flowing, and it depends only on the cell, or it's a property of chemicals. એને physics સાથે કાંઈ લેવા દેવા નથી, frankly, right? If you say that this cell has 1.5 volt EMF, then why is it 1.5 volt? You will get that answer in chemistry, right? You will not get that answer. You will not get that answer in physics, right? Okay, and this minus IR stands for how much voltage is decreased inside the battery itself, right? Because of its internal resistance. So basically, you can say that battery the અંદર જ એક resistor જેવું છે, which is wasting energy, right? So this is going to waste energy. I hope you understand what I'm saying. Okay, so that's the important relation. Okay, હજી આમાં એક બહુ મોટી ગોલમાલ છે. Let me explain that as well. When battery or cell makes current flow, what? No, sir. Exactly, Avinash, that's the reason. That's the reason. When battery or cell makes current flow, that is battery is discharging. Okay, that is battery or cell is discharging. That is used. Okay, you are using it, At that time, V is equal to epsilon minus IR is correct. There's no doubt about that. Okay, હવે એનો opposite case. હવે એનો opposite case. When battery or cell is getting charged by other battery, of course of more EMF, okay, or of more voltage, ખાલી એટલું લખો તો ચાલે, right? So when battery or cell is getting charged by other battery of more voltage, at that time V should be equal to epsilon plus IR. Okay, what's the reason for this? The reason is because current flows in opposite direction. Okay, so these are two formulas actually, but if you remember what's going on, then it's not confusing. Here the battery or the cell is being used, means you are consuming the energy from the battery, right? The battery discharge. Okay, at that time, this is what we have, right? Okay, but sometimes we have to charge the battery also, right? I'm sure you have charged your phone's battery, right? Or there are some rechargeable cells. At that time, the circuit actually looks like, this. Suppose this is the battery which we want to charge. Okay, suppose this is what we want to charge. Okay, right? Let's call it cell 1. We want to charge cell 1 or battery 1. So to charge that, what we will do is we will connect it with a larger voltage battery. જો આવી રીતે કરો ને એને બેટરી કહેવાય. આમ તો બધું બેટરી જ કહી શકો, but this indicates multiple cells. Okay, I hope you understood that, right? So when we connect it like that with some larger voltage battery, right? So what's going to happen is current will flow like this, which is opposite. If you realize, હજી આમાં બીજું બધું હોય પણ આ તો ખાલી એકદમ simple word, right? This is opposite of what happens when you are using a battery to run or to use another device. Let's say a bulb. I hope you see the difference. I hope you see the difference. Right? So here, this cell 1 is getting discharged. Here the cell 1 is getting discharged. And here the cell 1 is getting charged. I hope that makes sense. Clear? Okay. ઊંધો current flow થાય તો કેમ charge થાય? The answer is as follows. If you look at the previous drawing here, what did I tell you? It's that the electron, it's that when you are using a battery by connecting with a resistor and all that, when you are using a battery, at that time this electron goes like this. So it is actually that oxidation happens over here and reduction happens over here. Okay, I hope you understand that, right? Because electron is coming out from here. It means અહીંયા oxidation થયું હોય ને તો જ electron બહાર નીકળે ને, right? And અહીંયા reduction થાય because here the electron is going and it's going to react with it. Okay, but when the direction of current is reversed, when the direction of current is reversed. So that at that time the electron will come out from here. I hope that makes sense. And will go in there. Right? Electron will come out from here and it will go in there. So what is happening is here there is oxidation and here there is reduction. Agreed? Right? So during such a process where you connect a larger battery or larger voltage and make the current flow through it opposite to the normal way, opposite to this way, right? So what happens is અહીંયા જે કઈ reactions થતા હતા હવે અહીંયા એનાથી ઊંધા reaction થાય, reverse reaction, all right, or backward reaction in chemistry language. I hope that makes sense. Okay, so there will be backward reaction. Okay, so when that happens, the internal internal chemistry of the whole battery will start to get reversed, and the energy non electrical force see consume થઈ ગઈ હતી ને એ હવે બધી પાછી આવશે, right? I hope that makes sense, because when the charge flows like this, the non electrical force, I repeat, the non electrical force makes the potential energy of that ion increase. So if potani energy consume થાય ને, I hope you realize that energy of the or energy due to the non electrical forces will decrease, right? Energy of the non electrical forces will decrease and potential energy of the ion will increase. અને હવે reverse process કરો તો ion left to right નથી જતો, હવે ion right to left જશે. Okay, I hope you understood that. So at that time the non electrical forces will get their energy back. So that's a charging process, right? એટલે આવી આખી બધી સાયકલ ઊંધી થઈ. Exactly everything is in reverse. Okay, so that's what happens during a charging process. એટલે current ઊંધો flow થાય, reactions બધા ઊંધા થાય, right? So then what happens is that if you would sorry, just a minute, if you just have a look at this equation and derive yeah, here, if you just have a look at this equation, do you realize that these two will get reversed? Now we will have VB minus VA equal to minus IR and VA minus VB equal to IR during the charging process. Yes or no? Did you understand this? Did you understand this, everyone? Because current is flowing in opposite direction. Because current is flowing in opposite direction. બરાબર? તો હવે ઈ જ ટર્મ તમે અહીંયા આગળ લઈ જાઓ અને પછી આપણે જે કેલ્ક્યુલેશન આગળ કર્યું હતું તો એમાં ક્લિયરલી અહીંયા માઇનસ ની જગ્યાએ પ્લસ થઈ જશે. I hope everyone understood that, right? So that's the whole full detailed reason. બરાબર? હવે આનાથી વધુ કંઈ સમજાવવાની મારા ખ્યાલથી જરૂર નથી. That why do we get plus IR here in the charging process? Yes, Darshi, do you have a question? If so, you could ask it. Okay. Right. Fine. All right, Darshi, I was waiting for you. Never mind. Okay, you can type it. Meanwhile, let's draw a graph. Okay, terminal voltage versus current through battery. Let's draw a graph of this, right? It's going to be very interesting. No, Darshi, you will not need to derive. Everyone in your book, I don't think derivation is also given, or maybe it's just one or two lines. Okay, but you never need to derive it for charging process. Let me tell you everything. Okay, you don't have to worry about deriving anything for charging process. Overall, even the definition, or no, almost like we don't get a question like prove this. Okay, I repeat, we typically don't get questions like prove v equal to epsilon minus I. Okay, most of the times the questions from this topic, right, direct or theory questions from this topic are like definitions. Okay, the three definitions, like what is terminal voltage, what is internal resistance, and what is EMF. EMF is everybody's hot favorite definition of EMF. Okay, બાકી આ formula આવડવી જોઈએ ખાસ, right? The formulas are important because we use them in numerical. હવે આ જે રોજ 10 જણ જતા રહે છે એમને શું કરવાનું, આપણે ઇગ્નોર કરવાના ને હવે એમના ડાઉટ આવે તો એક વધુ હોય. No, they don't want to re-enter, Avinash. Okay, it's not like they have gone by network problem or anything. બસ હવે થાકી ગયા, બસ હવે અમે નહીં ભણીએ એવું છે. Or we could actually congratulate them on their punctuality. ચલો વાંધો નહીં. Equation શું છે? Equation is V is equal to epsilon minus IR. Correct? Okay. So here I'm going to draw I, and here I'm going to draw V. Okay. એવી રીતે કરીએ છીએ. Right? So now, if we draw a graph, I believe everyone understands the graph will be a straight line like this. Agreed? Y equal to mx plus c. બરાબર ને? પણ આમાં c પહેલા છે અને mx પછી છે. એવી રીતે. Okay. X is I, Y is V. Right? Okay, so this point should be epsilon. Agreed? I don't think anyone is surprised by that. Okay. બરાબર ને? સમજાણું ને કે ન સમજાણું? I said that here at this point current is 0, so voltage should be epsilon, terminal voltage is EMF, right? Open circuit. બરાબર ને? Current is 0 એટલે open circuit. Yes, very good, Kodal, that's right. Okay. Slope of this line is minus R. બરાબર? What's this point? What's this point here? Here you have voltage equal to 0 and current equal to epsilon by R. Yes, very good. Okay. Right? So this is actually the maximum current possible. I hope you realize that. આનાથી વધુ શું નેગેટિવ થોડું જાય, વોલ્ટેજ થોડો નેગેટિવ આવે. બરાબર ને? This is the maximum current possible. Right? Generally when this happens, this is called short circuit. Right? When this happens, this is called short circuit. આ ક્યારે થાય? કોઈ કરશે નહીં હો. Warning, don't try it even with a cell. Don't do it. Okay? This can be done if you take a cell. Okay, if you take a cell and don't connect anything, ખાલી એક copper નો wire લાવીને આમ અડાડ દો એટલે boom. Right? Now ખાલી મજાક કરું, explosion નો થાય, but there will be sparks, there will be fire. Okay, if you are not paying attention, there will be fire, right? Yes, Avinash, that is right. That's why the rating is given. બહુ વધારે કરંટ લેવા જાવ ને તો ગરમ થઈ જાય. ઓકે, સો ધીસ ઇઝ વેરી ડેન્જરસ અગેન. પછી કાલે ન્યૂઝપેપરમાં આવશે ઘર બળી ગયું તો હું સમજી જઈશ કે તમારામાંથી જ કોક હતું. Do not try it at home. Okay, so with that we are going to stop here. All right, આ બધો ગ્રાફ અને ફોર્મ્યુલા ખાસ યાદ રાખી લેજો બે. Okay, so next time we will solve questions regarding this. All right, goodbye everybody. Please make sure you remember the formula. Of course, Podal. આપણે કઈ ટાઈમ પાસ તો કરતા નથી, કંઈક તો જાણવા મળે. Goodbye everyone.